Hi guys, so today I'm going to share with you my experimental tip, which is the DIY Venturi Tube low-cost experimental kit for pressure analysis of Bernoulli principle. The objective of the experiment is to demonstrate the application of Bernoulli principle and the Venturi effect in fluid dynamics. As we know, Bernoulli principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or decrease in the fluid potential energy. Next is this experiment hypothesis. The fluid velocity increases as the cross-sectional area decreases, leading to a decrease in pressure as was stated in Bernoulli principle. In this experiment, we have three variables, which is cross-sectional area, velocity of air, and pressure. For this experiment, we use apparatus and material which is low cost that we can get in our daily life easily. For example, we use plasticine, plastic tube, colored water, use water bottle. All this material and apparatus we can get it easily at our house or school, or we can buy it in the nearest hardware store. Next, we look at the procedure on how we want to conduct this experiment. See, we need to cut the water bottle in a rectangular shape, and we need to shape the plasticine as the shape of a Venturi tube inside the cut plastic water bottle. We cut three pieces of plastic tube and arrange it next to each other as shown in the picture. And we put water, same quantity of water in each plastic tube. We need to arrange all the material and apparatus that we have made according to the picture. And lastly, we need to insert a long plastic tube into the Venturi tube that we have made. To do this experiment, we need to blow air in the long plastic tube, and then we need to observe what happened at the three plastic tubes that we arranged next to each other, and then we record what we observed and we analyze to get the pressure difference in each region. In the setup shown, air flows from right to left. When passed through the narrow space in the middle of the tube, the velocity of the air increases. As the air needs to follow faster in the constricted area, the change in air velocity also affects the pressure. So as we see, the water level at the middle tube is higher compared to two other tubes. It proves that at the narrow area, the velocity of air was high and forced the water to be sucked in, and it indicates that the region has lower pressure. Based on the picture shown, the water level that is nearest to the air supply it moved slightly, which indicates higher pressure region at the wider part of the Venturi tube. This means that the region has lower velocity of air, create higher pressure. The water level in the plastic tube that located furthest away from the air supply does not show any change. This happened due to several factors. Later we discuss the factors. So let me discuss what we have done in this experiment. The accuracy of the result obtained from the DIY Venturi tube may be lower than that of a commercially available Venturi tube. Based on the collected result, the tube that located furthest from the air supply does not show any changes. Why? The best reason why this occurred was due to inconstancy of the airflow, and the plasticine used was not airtight, and it allowed air to escape to the tiny spaces in between the plasticine and the tube. For the conclusion, we have successfully demonstrated Bernoulli principle and determined the pressure difference at higher velocity of air compared to lower velocity of air. The Venturi tube is a valuable tool with various industrial and scientific applications. When used in DIY setup, the Venturi tube can be employed to measure flow rate of fluids and demonstrate the Venturi effect. The use of a Venturi tube in DIY experiment allows for hands-on learning and practical understanding of fluid dynamic principles. Although the designed kit has a few disadvantages, it can be improved to give better results. In conclusion, the DIY application of the Venturi Tube offers a cost-effective way to explore fluid flow and pressure difference. By constructing and using the DIY Venturi Tube, individuals can gain insight into the practical application and the fundamental principle of fluid dynamics, making it a valuable education tool.